Okay, let's continue. Taking a look at the exercises. Graph each polynomial function. Estimate the x-coordinates at which the relative maxima and relative minima occur. So for this first problem, I'm going to make an xy table. And let's go ahead and use our graphing calculators to type in the function x to the third minus 3x squared. Okay, zoom 6. And here is our cubic taking shape. Now, as you can see, the end behavior, as we should predict, is down and to the left, up and to the right, because it is a positive odd function. Furthermore, it appears that we have a max, relative max here, and a relative min there. But let's go ahead and make a table of values hitting second graph. It would be easy to manage here. I'm going to go ahead and pick values -1, 0, 1, 2, and 3. That should be plenty. Okay, so if we refer back to our graphing calculator, -1, -4, 0, 0, 1, -2, 2, -4, and lastly 3, 0. Okay, so we'll plot these points. -1, -4, 0, 0, 1, -2, 2, -4, and then 3, 0. Okay. Again, using the graphing calculator as an aid here. Go back to my graph. I can see that it will go up through two values and appear to have a max value, like I said, at 0, 0. Let's go ahead and start the graph going by hand here. And then, put a little arrow there, and then it appears that, going back to the graphing calculator, it has a minimum at 2, -4. So, and then back up. Okay, now to prove that we do in fact have a relative max or min, we're going to go to the calculator and we're going to hit second, trace, option number 4 first for maximum, so option 4 is maximum. I'm going to do the same type of thing that I would do if I were finding zeros. I'm going to create a left bound. The left bound here, though, will have a negative y value, as will the right bound. And the reason is that the point 0, 0, 0 appears to be the max, but it certainly will have a left bound that is going to have a negative y coordinate and a right bound also a negative y coordinate. It has to have it because this value does not go above the x-axis. We'll hit enter there. I'll scroll to the right and hit enter there, and then hit enter again. So, okay, this is an interesting couple of values. Sometimes the calculator will not give you exactly 0 for either x or y. But if you think about how close this particular value is to 0, right, 4.78 times 10 to the -7th, we've got 0.000, we've got 6 zeros, and then the number 4. So that's really close to 0. So we're going to say that that's 0, and then the same thing goes with the y coordinate. So it is, in fact, true that 0, 0 is a relative max. And we're going to identify the x value in this instance only here, x equals 0. And then this particular point down here, we're predicting it's 2, -4. But to prove it, we'll go ahead and use the calculator, hit second trace, option number 3 for minimum, scroll to the right. I'll stop my cursor, let's say there. I want to be to the left of the min value, so hit enter, Scroll to the right, and I want to be to the right of the minimum value. Hit enter. So there's my left and right bounds. Hit enter again, and there you have it, 2, comma, -4. So as predicted, that is in fact our other extrema value. We call it a minimum, and that simply becomes then, as far as our final, a relative min at x equals 2. Okay, let's do one last problem here. We'll take a look at a fifth degree function, number 5. Now this fifth degree function is, first of all, let's just point to the degree here. This is an odd function, and it's also a positive leading coefficient. So we should note very similar relationships as far as the end behavior goes as it relates to number 1. Let's go ahead and type it in and see what we can plot as points. So x to the 5th, let's clear that. X to the 5th minus 2x squared plus 2. Okay, zoom 6. Here's our function. It actually looks very much like a cubic. Okay, it does have the end behavior as we anticipated, down and to the left, up and to the right, as all positive odd functions look. Hit second graph, and we're going to go ahead and use some values. There's not too many here that I really like, so it really appears that only 3 are going to be useful here. -1, -1, 0, 2, and 1, 1. Sometimes this is just going to happen. The function has very small and very large values. Here's their small values and very large values there that are not going to be easily graphed. So I'm going to go ahead and just graph these 3 points, but still use our graphing calculator as a helpful aid. So here are the 3 points that I'm going to use. Go back to our graphing calculator and see there that it appears that the graph well goes up and stops at a max of 0, 2, down at a min of 1, 1, and then back up again. So let's draw that as follows. So there we go. And yet again, we're going to go ahead and use our graphing calculator to help us, hitting second, trace. Option number 4 for max. Left bound, I'll stop here. Right bound, I'll stop there. Guess, and yes, that is approximately 0. It is close to 0, we should say. So 0, 2, that is our relative max. And of course, we're just going to identify the x-coordinate there. And then the relative min, as our prediction was at the get-go here, that it will have an x-coordinate of 1 and a y-coordinate of 1. Let's go ahead and use our graphing calculator one last time. Second trace. Option number 3 for minimum. Scroll to the right. I'm going to hit enter roughly here. Scroll to the right again. Again, you want your left and your right bound to be to the left and to the right, respectively, of your value that you're trying to find. Hit enter, and then enter again. And, well, that value is, again, really close to 1, as is that value. So we are going to officially confirm here that this value, 1, 1, is a relative min, and therefore x equals 1 is the x value for that particular relative minimum. This concludes our lesson for 6.4.